curious minds, welcome back to ProjexCellence ProDigy, your one-stop solution for all your project management and mechanical engineering needs. I'm Govind, a certified PMP and a mechanical engineering professional. Today, we are going to understand a very important and practical concept: energy flow and heat balance in an internal combustion engine. Let me start with a simple question. When fuel burns inside an engine, does all the energy become useful power? The answer is no. An internal combustion engine is a machine where the chemical energy of fuel is released inside the cylinder and converted into useful mechanical output, along with several unavoidable losses. So clearly, not all fuel energy becomes useful power. Now let's understand where this energy goes. First, the biggest loss is through exhaust gases. After combustion, very hot gases leave the engine, carrying a large amount of heat energy with them. Second, cooling losses. The engine operates at very high temperature. So, cooling water in HT and LT circuits removes heat to protect engine components. Third, lubricating oil losses. Lubricating oil reduces friction, but it also absorbs heat from engine parts. Fourth, radiation and miscellaneous losses. Some heat is directly lost to the surroundings through engine surfaces. And finally, friction and pumping losses. Not all the generated power reaches the output shaft because some of it is lost in friction between moving parts or pumping the exhaust out of the engine. Now let's understand the complete energy flow. Fuel energy enters the engine and a large portion is lost as heat through exhaust, cooling, oil and radiation. And the remaining energy acts on the piston, and this is called indicated power, IP, the power developed inside the cylinder. But even this is not the final output, as this power is transmitted to the crankshaft through connecting rod. And some energy lost due to friction and mechanical resistance. And what finally remains is called brake power, BP, the useful mechanical output available at the shaft. Based on this energy flow, we define three important efficiencies. Indicated thermal efficiency. It tells us how efficiently fuel energy is converted into power inside the cylinder. Here. So indicated thermal efficiency will be indicated power divided by mass of fuel into calorific value. Brake thermal efficiency. It tells us how much useful power we actually get at the shaft. And the formula of brake thermal efficiency is brake power divided by mass of fuel into calorific value. And third is mechanical efficiency. It tells us how much of the power developed inside the cylinder reaches to the crankshaft. And the formula is mechanical efficiency is equal to BP divided by IP, brake power divided by indicated power. Now let's understand the energy flow with a real engine example. We have an 18V32 engine which is operating at 750 RPM and producing 8280 kilowatt of output, or this is the brake power. If you see the design data sheet of this engine, the heat distribution is HT circuit, loss is 2281 kilowatt. LT circuit loss is 2113 kilowatt. Exhaust gas loss is 5805 kilowatt. And radiation loss is 377 kilowatt. And the useful output is 8280 kilowatt. If we add all these values, the total heat input comes out to be 18,856 kilowatt. This represents 100% fuel energy. Now let's look at the percentages. Here we can see only about 44% of the fuel energy becomes useful output. Around 31% is lost through exhaust gases. And about 23% is lost in cooling systems. And nearly 2% is lost through radiation. So it clearly shows more than half of the energy is lost. And the biggest loss is through exhaust gases. Now here comes the real engineering intelligence. To utilize this waste energy, modern power plants use combined cycle technology. In a combined cycle power plant, the hot exhaust gases are not wasted. Instead, they are passed through a waste heat recovery boiler. This heat is used to generate steam, and that steam is used to run a steam turbine or for heating applications in auxiliaries. So what was earlier a loss now becomes useful energy. If you found this explanation useful, don't forget to like, share and subscribe to ProjexCellence ProDigy. Namaste, goodbye, Sampai Jumpa.